In this video, we're going to look at the maximum spacings for supports for steel wire armoured cables in accessible positions. We've all seen it before on the outside of a building, and even more so now with EV charging. An armoured cable clipped using cable cleats, and when it's done correctly, it looks super neat, but we've also seen examples when those supports are less frequent than they need to be and the cable starts to sag. We've also seen, I love your comments below, people using penny washers on steel wire armoured cable cleats in order to increase the support of the screw against that cleat. And if you've been trained to do that, please leave the comments below, or if you've got any other feelings on that as well, leave those. So it means we're going to be into the on-site guide, and we're going to be looking in Appendix D for supports of our cables. And we've used this table before, so if I turn to the page with table D1 on it, we're going to make some annotations at college on this page. And it might be that you're not comfortable drawing in your book, and therefore when you get to an exam you get your book taken off you because obviously you've written into it. And the little trick is to use a post-it if you're a bit nervous about writing in your book. I'm going to write on the table behind here, which is a copy of table D1, and we've used pictures before like this when we use flat profile twin and CPC cable or twin and earth cable. So bring a piece in there, we looked at the clipping distance of that, so my learners would have that picture on there or on a post-it. And we've added this one in here to remind us of the diameter of a steel wire armoured cable, which we need within this table. So let's look at table D1 next. There's some bits we may have already highlighted if we've seen some of our previous videos, but I want us to highlight those if we haven't, you've jumped in at the steel wire armoured, that the spacing of supports is in accessible positions, and that's quite important. So accessible positions for these cable clipping distances. And then we look at column 1. This is often thought about the millimetre squared of the cable and not the overall diameter of the cable. So this is the diameter in millimetres. So I get my learners to highlight diameter and millimetres against column number 1. Another thing worth noting is the section here at the bottom where there's some notes. It says horizontally and vertically, you're still classed as those two if you're within 30 degrees of what we would think would be horizontal and vertical. I'm sure at college you're never going to get away with supporting a steel wire armour cable that isn't dead straight, either horizontally and vertically, but you can drift up to 30 degrees away from that and still be classed under BS7671 as horizontal and vertical. Next thing we need to do is look at the top columns here, and we worked before in this section here where we were talking about thermoplastic and thermosetting cables that were non-armoured. Okay, well we're not, we've got a steel or armoured cable, and this one here says armoured cable, and sometimes I get my learners just to write SWA in there. So steel wire armoured cables means we're going to be using columns 6 and 7 for horizontal and vertical maximum cable supports. In other words, the maximum distance between our cleats. We might end up calling them clips during this video, but yeah, the cable cleats. And these are the sort of things we're used to seeing as our cable cleats in order to support steel wire armoured cable. You can obviously get metallic ones if you're worried about inside a surface wiring system of steel wire armoured and you're worried about premature collapsing. You can also get a metal version of those that are infrequently installed in order to support the cable so it doesn't collapse and become an entanglement risk during the exit of the building in the event of a fire. But for us, we're thinking of these plastic ones at college when we're supporting our steel wire armours over very short distances. But we need to know what the maximum space between those cable cleats can be in order that we can conform to BS7671. So as we look here, we go back to column number 1, we see the diameter. And again, I would get my learners to draw it in. So let's draw it in at the bottom here. I end up drawing a round cable. I put 3 internal conductors, and I say the outside widest part of the cable, as it's round, it wouldn't matter which side we went off, is the diameter. So that is the diameter as a little key to remind us. Remember, you could do that as a post-it. So it's the widest part of the cable to give us our diameter, and then that works in column number 1. And if you look here, column number 1 as we follow it across, so the diameter equal to 9, so from nothing to 9, the diameter of that cable. If we scroll along to where we get to 6 and 7, you can see there is no horizontal and vertical clipping distances. Therefore, a steel wire armoured cable hasn't got a diameter that small. So we're only working within these 3 here and these 3 here as our maximums. And again, note, as we go up the cable diameter, the actual spacings get further apart. So when the diameter of the cable is quite small, we can see our clipping distances are 350 and 450, but it gets larger and larger. Those clipping distances for the cable cleats is further apart. which is quite self-explanatory in some ways because the cable is quite rigid. So as we hold that cable there at each end, we can see there is no sag. So the larger the conductors inside it, therefore the larger the diameter, the more self-supporting the steel armoured cable will be. So we're going to have to measure the diameter of the cable, which means we're going to need to use our rule. Now I could measure it on the end of the cable, so if I just bring it up here and look at the end, but you can see it's a little bit squashed where I cut it, so it'll be slightly out of being round. To overcome that, we can actually measure the diameter on the outside of the cable like so. So if we bring the camera around there, I think we've got about 14 millimeters thereabouts. So the diameter of that cable is 14 millimeters. So if I wanted to work out the maximum distance between our steel armoured supports, our cable cleats, if we're using cleats, we need to take 14 millimeters, come to column number 1. We know it's not the first line. Okay, so we're down to the second one. So it's diameters over 9 and up to and including 15. So we're between greater than 9 and up to 15 for the diameter. And we just said our diameter was 14 millimeters. So our cable cleats positions would be looking at column number 6. Horizontally, 350 mil as a maximum. We could be under the maximum, but we couldn't be over it. And vertically, we would be 450. So we can see those two clipping distances there. And it's often in an exam, you're asked to find them using this table. They'll tell you normally the diameter of the cable, and you're expected to work out what your cable supports would be. If we just move to a slightly larger steel armour cable and repeat the process, if I hold that on the outside there, and we try and see what that diameter is, I've got that at approximately 16 mil. Just depends how you're looking at the rule. So 16 millimeters for its diameter. Hopefully already you're thinking we've moved down a line. So let's just prove that. Go back to column number 1. So our diameter is greater than 9 and up to 15. We just said ours was 16. So we drop down here. So we're greater than 15 and equal to 20 for this line. So we know we're greater than 15 because our diameter was 16 mil. So we're going to use this row here. And as we follow it along to columns 6 and 7, we can see here that we've got a clipping distance for our cable cleats no greater than 400 mil horizontally and 550 vertically. So that would be our cable supports in those positions. So this table here can be used in the exam in order to work out thermoplastic PVC cable clips that we've done before. I'll leave a link in the description to that video. And we've now used the same table D1 in order to work out our maximum cable supports for steel armoured cable. Now, it might have been during the video that you spotted this gland here, which is a CW steel armoured gland. And you might be thinking, I wonder what the parts of that gland are. In order to find out that, check out the video just over there.